course, very, very important. We will pass after learning this course. Okay. So this 1 minute. So a warm welcome to you all once again. So this is very, very important for you in a theoretical purpose. So please go through this. Okay. So good evening, guys. I will start now. Okay. Let's start first. 1 minute. I'll share again notes. So let's start first. The first topic is continuous distributions. And I will blue. What is in continuous distribution? Continuous distribution is a random variable which takes countably infinite when there is no cutting point, no fixed point. It is lies in an interval that is called continuous distribution. For example, if I want to measure the chair, so chair or table or lie in that interval of chair, you will not be count. Okay. The length of the chair should be in inches. Okay. In some interval. So length. Okay. So it will not be like 1 inch, 2 inch. It lies in certain interval. So 1 to 2 meters, 1 to 2, sorry, so length there should be calculated. 1 inch width, 2 inch width, like that. 2.2 inch, 2.1 milli-inch, like width they will measure. So like that. That is a continuous case. Even discrete case is what? Is a particular fixed number. I want the 2 pieces or 3 pieces, 4 pieces, 5 clips, like that. So that is a discrete case. So according to this continuous, I'll read this. There are some distributions. Here in your syllabus, Dirgha Chaturasra Vibhajanam, that is rectangular distribution. What is normal distribution? Another one is normal distribution too. Okay. So part 1, Dirgha Chaturasra Vibhajanamu మరియు దాని భాజకాలను నివర్తిస్తాం. So that is. So what does mean Dirgha Chaturasrakara Vibhajanam? Rectangular distribution. The main objective of rectangular distribution and those applications we will read here. So here Dirghachaturasra లేదా ఏకరూప విభాజనం. This is the density function is the random variable lie in the interval a comma b and its density function f of x equal to k where a less than x less than b. 0 otherwise. The total area density is 1. Okay, a to b kx dx equal to 1. Where k is ab, that is k into b minus a equal to 1. By integration, we will get the value k equal to 1 by b minus a. So that is the density function of rectangular distribution. So here, this is So here, this is rectangular distribution density function. 1 by b minus a, where a less than x less than b, isn't it? So next, we need to find out the properties of density functions are all density function is always positive, that is f of x greater than or equal to 0, and total probability is equal to 1. So that is property is the lie distribution is continuous distribution lies minus into plus infinity. Here the interval is a to b. So a to b equal to 1. So that we have to check where a to b f of x dx equal to 1. That is a to b. The density function is 1 by b minus a. If you substitute in interval b minus a, you will get 1. So that we proved f of total f of x dx is 1. Okay. So next one, this is. So here, Vibhajana Prameya distribution function. The distribution function formula is this. Capital F of x equal to probability of x less than or equal to x. At x point, we have to define the distribution function. So in the integration, minus infinity to x, f of x dx. So minus infinity x, f of x dx. We know the f of x value is 1 by b minus a. So if you substitute here this, you will get x minus a, b minus a. So this is a distribution function. This is a distribution function. Okay, next. So this we can write as the distribution function is like this. So to write the distribution function, we know that distribution function 0 minus infinity less than x less than a, where a to b is the function is x minus a by b minus a, where b to infinity is 1. This is a function of f of x, capital f of x. So here f of x అనే ప్రమేయము x equal to a మరియు x equal to b వద్ద అవిచ్ఛిన్నం కానందున ఆ బిందువుల వద్ద ఇది అవకలనీయం కాదు. So that is d by dx of f of x is where f of x is equal to 1 by b minus a not equal to 0. So this is a continuous property we are checking, where capital F of x, where x equal to a మరియు x will b వద్ద అవిచ్ఛిన్నం కానందున means why here this the probability is lies a and b. So that's why while differentiate this function, we'll get it will not be x minus a by b minus a. So will not be equal to 0. Will not be equal to 0. So it's not differentiable. That means it's not differentiable now. So now, so x equal to a మరియు x equal to b వద్ద తప్ప ఎక్కడనైనాను వ్యవస్థితం అవుతుంది. పర్యవసనంగా సంభావ్యత సాంద్రత ప్రమేయము కింది విధంగా ఉంటుంది. That is x f of x, where a to b 1 by b minus a. So this is x distribution function f of x. The points is a to b. This is the density function curve. This is the distribution curve. This is the density function. Okay. So why the distribution function is a to x minus a by b minus a. Here x, a to b, where the point is 0 to a, 0 to a. Next, x minus a by over b minus a. Next, b to infinity. Next, b to infinity. That's why this is the curve of distribution function. And once, if you take a to b, where a is minus a, b is a, then the distribution density function will be 1 by 2a. So this is. So how to find the moments of distribution function? How to find moments? You know that moment, the formula, mu r dash equal to minus infinity plus infinity x or f of x dx, where mu r dash is a to b x to the power of r. Density function is 1 by b minus a. X belongs to a, b. So 1 by b minus a, while integrate x to the power of r plus 1 by r plus 1, where the interval is a to b. So this is the function of, in general, function of not rth order moment of non-central. B to the power of r plus 1 minus a to the power of r plus 1 by r plus 1 into b minus a. Well, substitute or equal to 1, b square minus a square by b minus a by 2. That is b plus a by 2. So first order moment of rectangular distribution value is what, ma? B plus a by 2. Okay. B plus a by 2. Minus a into 3. So a plus ba plus values cancel. You will get b square plus ab plus a square by 3. Okay. That is third order, mu2 dash. Mu2 dash is this. Next, variance. That is the formula. Next, r equal to 3, you will get mu4 dash. that is b cube minus a cube 5 into minus 5 into b minus a. What is the way? Formula mu2 equal to mu2 dash minus mu1 square. So that is a square plus 3 minus b by. So if we will get this is unmute. Sorry, this is unmute. Again, this I'm explaining you rectangular distribution over the interval is 1 by b minus a. The total probability is equal to 1. That is the properties f of x greater than equal to total probability is 1. We know that there are random variable lie a and b. Its density function is 1 by b minus a. We can check this by integrating this. So next, moments. This is the graph of the distribution function where capital F of x is probability x less than or equal to x. Okay, x less than or equal to x. When you substitute, you will get x minus a by b minus a, and total probability is 1. So now the moment formula is mu r dash is expectation of x power of r, that is minus infinity plus infinity x power of r f of x dx. The density is 1 by b minus a, x power of r by b minus a dx. Where r equal to 1, where x you will integrate, you will get 1, that is you substitute a to b, that is b to power of r plus 1 minus a to power of r plus 1 by b minus a r plus 1. Well, you cancel, you will get b plus a by 2. While you mu2 dash, you will get b square plus a square plus ab by 3. Similarly, if you substitute r equal to 3, you will get mu4 dash, that is b cube minus a cube by 5 into b minus a. So mu2 equal to mu2 dash minus mu1 dash whole square. So we'll get this b minus a whole square by 12. So now mu r in central moments, that is expectation of x minus expectation of x whole power of r. That is expectation of x minus mean is a plus b by 2 whole power of r. That is a to b, when you substitute x minus a plus b by 2 whole power of r into f of x dx, you will get y equal to x minus b plus a by 2. Where you differentiate, you will get this a value c. If x equal to b, if you substitute b minus a equal to c. So that is the upper limit is minus b minus a by 2, that is we call minus c. The lower limit is b minus a by 2, that is c. Upper limit is c. So that is, so here minus c to c by 1 by b minus a by 2 power of dy. So if you substitute or equal to 1 by b minus a, the limits are minus c to c. So 2 into 0 to c. If you substitute 0, so all odd order mu3 is 0. mu3 is 0. Adevidanga mu1 is 0. So similarly, 5 also 0. All odd order moments are 0. Only it exists. The general formula mu r is b minus a whole power of r by r plus 1 by 2 r. 1 by 2 r. This is the in general formula. From this, if you write 2, you will get no 4. That value is, so b minus a whole power of 4 by 80. So here 2, 3, 5 or 0 and even moments are only exist. That is up to mu4 we find out the any distribution. So this is the value b minus a whole power of 4 by 80. So then skewness is beta 1, why it is v0. Now only we declared all other moments are 0. Okay. Next, b2 is mu4 by mu2 square. So mu4 is b minus a whole power of 4 by 80. mu2 is square, b minus a whole square by 12. So its value is 1.8, which is less than 3. So 3 కంటే తక్కువ కాబట్టి అది ఫలక మోపు రూపాన్ని అనుసరిస్తుంది. We know that flat T curve. Okay. So next one is Brahmaka movement generating function. Brahmaka Janaka Pramayam, because x follows u a comma b, that MXT formula is expectation of e to the power of dx, that is minus infinity plus infinity e to the power of dx f of x dx. So a to b e to the power of dx f of x dx. So next, so that is e to the power of bt minus at by t into b minus a. So this is, so from this we learn in movements, moment generating function, and all order movements, even order movements, and we find out the, check the PDF, check the distribution and distribution function, and beta 1 beta also we define. So these are the questions. Go through these questions, and these questions only will come in examinations. Please read. Next the topic is normal distribution. So now I'll explain normal distribution. This is a normal distribution. It's a very, very important distribution. So the one can use very important in all cases, biological science, physical science, mathematical science, in MBBS or in engineering, anywhere this distribution is very, very important. That is normal distribution. What is normal distribution? So this. So first, this word remover, 1667 to 1754, 73లో కనుగొనబడింది. ఇద్దరు అవకాశంతో కూడిన ఆటలో తలెత్తే సమస్యలను పరిష్కరించడానికి విభజన గమనికలని గౌసియన్ విభజనం అని కూడా అందరూ. ఫెడరిక్ గౌస్ దోషాల యొక్క గౌసియ నియమం 1755 తప్పు తీరాల శరీరాల స్వర్గపు శరీరం గణించడంతో ఆకారంలో ఉన్న వారి గణించడానికి లోపాలను నివారించి so these are is explain the density function of normal distribution. Is density function of normal. This is density function of normal distribution. It's not coming. This is density function of normal distribution. No, any problem. This is density function of normal distribution. It's not scrolling. This is density function of normal distribution. This is density function of normal distribution. Density function of normal distribution. No, it's not working. No, now it's. This is density function of normal distribution. So this is the form that is 1 by root 2 pi sigma e to the power of expression means here e to the power of all this is e to the power of e to the power power of x minus mu by sigma whole square. Here see this x minus mu by sigma, this all in power only whole square. Okay. Right, my 1 2 pi sigma. We can add mu of for the greater than equal to 0 and probability is 1. So those are the properties. We apply those properties will be proved. It can be proved. So those these are the plus mu dx equal to sigma dj. Next, this is PDF we need to check. So one properties f of x is greater than equal to 0 and total property is 1. Here density is 1 by root 2 p whole power of minus half by sigma. So that you write, and you have to take the limit minus to plus infinity here. So by integration purpose, we will take x minus mu by sigma is z, where x equal to mu plus sigma z, where equal to sigma dz, dx equal to dz, dx equal to sigma dz. Then you substitute, you will get root 2 pi sigma dz. So here minus 2 plus infinity minus z. So z square by 2. Sigma z and sigma get cancelled. You will get 1 by root 2 pi minus plus infinity e to the power of minus. Hello? Some network issues. Please, once again, I am going to start this. I am sharing the notes. So here we proved that 1 by root 2 pi minus into plus infinity e to the power of minus z square to dz. So this is the density function we got. So now z square by is t, where z square equal to 2t, 2z dz equal to 2dt. Now you substitute dz equal to 2 by 2z. So that is dt by z. 2 gets cancelled. Where so this is I started my video and see this now the square by 2 is now this dz equal to dt by z, where z equal to root 2t. So in this density function minus 2 plus infinity f of x dx, f of x dx, which 1 by root 2 pi not, this is what dz equal to dt by z. So here 1 by 2 pi minus 2 plus infinity e to the power of minus t. How j by 2 is here t, e to the power of minus t. So d is 1 root 2 t means root t. So 2 pi is, I'll tell. So that is 2 pi is what? So 1 by 2 pi. So that is dt. That is 1 by pi 2 into 0 to infinity e power of minus t, 1 by root 2, 1 by root t dt. So 1 by root pi, that is 2 into root 2. You can write that root 2 by root 2. That is 2 by root 2 into root 2. That will get cancelled. That is root 2 pi. So that is 0 to infinity e power of minus t, t to the power of minus 1 by 2 dt. So that is root 2 can be written as 2 is can be written as, so root 2 get cancelled. So next 1 by root pi, r is 1 by 2. So root pi gets cancelled. We proved minus infinity plus infinity dx is 1. So next, mode. How can we find the mode? We know without properties f of x is 0. Or First differential f dash x is 0, f double dash x less than 0. These are the properties of mode. So this you apply in your density function. So differentiate the density function. So while this is a impossible to differentiate because numerator and denominator, that's why we have to take the log, where log f of x log of this function. So while simplify log m plus log n log mn, log m plus log n. Log mn is log m plus log mn. Log m plus log n. So take together the log terms and this is a constant term. If you do the differentiation, you will get this value. So that is equal to mu f is f x is differentiate less. Now it is mid. Mid is the tension where expectation of x is at this point. We can find out median that to m f of x dx where m to infinity f of x dx is 1. So then m where infinity is 1, we get this function. So that is median is also mu. Median is also mu. We have proved this of the function is 1 by 2 and this function is 1 by 2. So we can prove that I'm sharing the notes this. Okay. So mean is completed, median is completed, mode is completed. We know that mean is mu, median is mu, mode is also mu. So in normal distribution, mean equal to median equal to mode. That we have proved here. Okay. Moment generating, we know that moment generating function formula mxt equal to minus infinity plus infinity e to the power of dx f of x dx, where that is mxt equal to minus infinity plus infinity e to the power of dx. The density function is 1 by root 2 pi sigma e to the power of minus of x minus mu by sigma whole square dx, where x minus mu by sigma is z, where dx equal to mu plus sigma dz. So that is mxt 1 sigma minus infinity to plus infinity, where z is mu plus sigma z whole square. Z is square um, uh, t mu plus sigma tz. So that is e to the power of mu t by root 2 pi minus infinity plus infinity e to the power of minus of z square minus 2 sigma tz dz. So next one is that is ut plus of t square sigma square. This is the moment generating generate the moments, differentiate this function and put equal to 0. You will get the first move differentiation and put the equal to 0, we'll get mean, mu. And also we can do double differentiation, second differentiation and put the equal to 0, we will get mu. And mode is also mu. So now is this X follows n mu sigma square, mu1 sigma 1 square, x y follows n mu2 sigma 2 square, where x plus y is follows n mu1 plus mu2 sigma 1 square plus sigma 2 square. So that is f of x equal to 1 by root 2 by sigma e to the power of minus of x minus mu by sigma whole square, where mxt equal to mu t plus of t square sigma square. So that is where mxt e to the power of mu t plus of square sigma square, where y is m by t e to the power of mu t plus of t2 square sigma 2 square. So that is x plus y, mx plus y t into t. That is expectation of t e to the power of t into x plus y. That is expectation of e to the power of tx, expectation of Hello, hello. Should I explain mean median mode? Mean median mode is completed. Okay. So we proved in normal distribution, mean equal to mu, median equal to mu, and mode equal to mu. It is a bell-shaped curve. So these are the properties, difference property and derivative property also I explained. Normal distribution with mu sigma 1 square, y follows normal distribution with mu 2 and sigma 2 square. Then difference also normal distributed. That we have proved here. That we have proved here. Mu 1 minus mu 2 sigma 1 square plus sigma 2 square. So that is. So now this is x for characteristic equation. So that is phi of xt equal to minus infinity plus infinity e power of dx f of x dx. So this same as same differentiation we need to follow, that is x minus mu by sigma is z, where x minus mu equal to sigma z, where x equal to mu plus sigma z, that is dx equal to sigma dz, where phi of x is 1 by root 2 pi sigma minus infinity plus infinity I dx mu plus sigma z, that is equal of z square by 2, that is. So now we claim that is phi of xt is mu ti minus half t square sigma square. So next cumulative generating function, that is called kxt, that is log mxt. So that is mxt is e power of mu t plus half t square sigma square, where kxt is log mxt, that is if you follow, that is where t యొక్క గుణకం mu k2 sigma square kr kx0 to the power of r by r factorial, where we know that in normal distribution is also all ordered moments are 0, even ordered moments exist, that is mu 4 equal to 3 sigma square, where beta 1 is mu 3 square by cube by mu cube, that is beta 2 equal to 3, beta 1 equal to 3. This is a perfect skew distribution where beta 1 equal to 0, beta 2 equal to 3, when beta 2 equal to 3 according to Curtis, which is a normal curve. So now central movements we can call Kendriya Brahmakalu. That is x follows normal mu sigma square, where mu lies minus infinity plus infinity, where sigma is positive, where r equal to expectation of x minus expectation of x whole power of r. This is central movement. We already told central movements are exist, non-central movements are not exist. So that's why you need to differentiate this, where r is odd, r equal to 2n plus 1, or is even, or equal to 2n. So here r equal to 2n plus 1, mu 2n plus 1 is, we follow that we will get by differentiation mu 2n plus 1 is 0. So all odd moments are 0. Now even are equal to 2n. There is mu 2n 1 by root 2 by sigma minus infinity plus infinity x minus mu y x minus mu. This is the central moment. Whole power of 2n. That is the distribution e power of x minus mu by sigma whole square dx. So here substitute x minus mu by sigma is z, x minus mu equal to sigma z, ds equal mu plus sigma z, dx equal to sigma dz, where mu 2n is 1 by 2 by sigma minus infinity plus infinity sigma z over of 2n e power of minus z square by 2 sigma dz. So if you will get this value is like this. So that is. mu 2n by mu 2n minus 2. We will get the value 2 sigma square n minus 1 by 2 mu 2n minus 2. Okay. So now madhyama will mean deviation about the mean. Minus infinity plus infinity modulus x minus mu f of x dx. That is minus infinity plus infinity modulus x minus mu f of x is this. So now if you find out the same differentiation we can apply, we will get mean deviation about the mean is the value is this. Okay, that is 1 by root 2 pi sigma. Root 2 pi sigma. So next one is Sati Pravartana Binduvulu. That is f double dash x is 0, f double dash x not equal to 0. That is x equal to mu plus or minus sigma. That is Samanya Vakraniki Sati Pravartana Binduvula Vada f double dash x is 0, f double dash x not equal to 0. That is f dash x is 1 by sigma square x minus mu f of x. Value differentiation again we will get f double dash x is 0. That is 1 minus x minus mu by sigma whole square is 0. Where x minus mu by sigma square is 1. Where x equal to x minus mu equal to plus or minus sigma. Where x equal to mu plus or minus sigma. So that is so f of x equal to 1 by root 2 by sigma e to power of half minus half అనగా అది మధ్యమం నుండి సమదూరం సిగ్మాతో ఇరువైపులా ఉంటాయి. దట్ ఈస్ మ్యూ మైనస్ సిగ్మా నుంచి మ్యూ ప్లస్ సిగ్మా. స్వతంత్ర సామాన్య చలరాశి యొక్క రేఖీయ సంయోగం కూడా సామాన్య చలరాశి అవుతుంది. సో దట్ ఈస్ వాట్ ఎవర్ xi ఈక్వల్ టు 1 2 3 n అనేది n స్వతంత్ర సమాన చలరాశులు. వీటి మాధ్యమాలు మ్యూ ఐ మరియు sigma square అయితే where mxit is e power of mu t plus of square sigma t square where రేఖీయ సంయోగము that is I equal to 1 to n ai xi. So that is a1 a2 etc an are constants where m summation ax of t is m a1 x1 plus a2 x2 etc an xn of t. That is mx1t, mx2t, mnxnt. Where x1, x2 are independent, we will get mx1 a1t, mx2 a2t, mxn ant. So that is mxt formula is e power of mu t of t square sigma square. So that is exp summation I equal to 1 to n ai mu I into t plus t square sigma square summation I equal to 1 to n ai square sigma I square. Where this is summation AIXI follows normal summation AI mu I plus summation I equal to 1 to n AI square sigma I square. So that is when the రేఖీయ సంయోగం కూడా నార్మల్ అవుతుంది. If x follows normal mu sigma square, if x follows summation AX, where it follows n summation AI mu I plus summation AI sigma AI square sigma I square. So this today we have discussed what we learned here. What is the normal distribution? What are the skewness and curtices? What are the all order movements or even order movements? Where mu 2n is sigma square into 2n minus 1 mu 2n minus అని చూపండి. సామాన్య విభజనానికి మధ్యగతము మధ్యమము బహుళకము సమానమని చూపుము. సామాన్య విభజనానికి mu 2n is the formula very important. That is sigma square 2n minus 1 mu 2n minus 3. Sigma square 2n minus 1 mu 2n minus 3. సామాన్య విభాజన యొక్క సంకలన ధర్మాన్ని ప్రవచించి నిరూపించము. మధ్యమం దృష్ట్యా మధ్యమ విచలనాన్ని రాబట్టము. n స్వతంత్ర సామాన్య చలరాశుల రేఖీయ సంయోగం కూడా సామాన్య చలరాశి అవుతుంది. n mu సిగ్మా స్క్వేర్ సామాన్య విభజనానికి నతి పరివర్తన బిందువులను రాబట్టండి. దట్ వీ హ్యావ్ ఫైండ్ అవుట్. సామాన్య విభాజనం యొక్క క్యారెక్టరిస్టిక్ ఈక్వేషన్ దట్ ఈస్ లాక్షణిక ప్రమేయాన్ని ఉత్పాదించము. సామాన్య విభాజన యొక్క బహుళకాన్ని కనుగొనండి. డియర్ స్టూడెంట్స్, వాట్ ఎవర్ ద టాపిక్స్ ఇన్ దిస్ Here, you learn there, those only will come in examination. See the previous papers and prepare well. If you get any doubts, and please WhatsApp my number, I will explain clearly. Okay. So these are we learned. This is a paper pattern. Please see. So I will stop. Please see. Um, if you get any doubts, I will explain. Okay. So please once go through these questions. The other questions are 1 to 8 and short answer questions are 1 to 5. Please read one by one. So please read one by one. You will get an idea and solve those questions. You will get full idea about the paper. And then you will easily write those questions. So if you read well and write the semester exams, okay. Now only I started at the same time. Tomorrow I'll meet you, okay. So if you have any doubt, once again I'm requesting you, I'm asking you. Is that today we have completed rectangular distribution, density function, rectangular distribution moments, rectangular distribution properties, rectangular distribution moment generating function, rectangular distribution, rectangular. So here what we observed, the rectangular distribution and normal distribution does not have the all order odd order moments. All odd order moments are zero here. So that's very, very important point note. And here normal distribution, the skewness is beta 1 equal to 0 and it is perfectly skewed distribution where beta 2 equal to 3. That's why it is a bell-shaped flatly normal curve. So whereas rectangular distribution, it is a flatty curve, falaka chaturasrakaramu, that is. So that's why where x equal to a and b, those are the points the curve is we have drawn. Okay. So these are the very, very important points I discussed. So please go through the notes once again. Okay. Thank you, BRAOU team. If any doubts, please share me. Read the questions and previous paper. One thing, get an idea. And tomorrow I'm going to explain Samanya Vibhajana Mode 2. This tomorrow I'll explain. Please go through this. Samanya Vibhajanamu 2. So one C, please. Hold the lane. So thank you, BRO, your team. Thank you.